What happens when you throw something into a black hole? You'd think it's gone forever, right? Crushed out of existence. But it's not that simple. In fact, this question leads to one of the biggest mysteries in modern physics, the black hole information paradox. It's a mind-bending puzzle that pits two giants of science, general relativity and quantum mechanics, against each other in a battle for the soul of reality. Let's back up. When physicists talk about information, they don't mean your secret diary or your browser history. They mean the fundamental, unique identity of every particle in the universe, its properties, its quantum state, its entire history. Think of it as the universe's ultimate fingerprint system. A core rule of quantum mechanics is that this information can never, ever be truly destroyed. You can scramble it, you can hide it, but you can always, in principle, reverse the process and figure out what you started with. But then, here come black holes. According to Einstein's theory of general relativity, a black hole's gravity is so intense that once anything crosses its event horizon, the point of no return, it's lost forever, destined to be crushed into an infinitely dense point called a singularity. It seems like the perfect cosmic shredder. So, what happens to the information? Does it get deleted? If it does, quantum mechanics is broken. If it doesn't, how does it escape a prison from which not even light can escape? This is the paradox. For a long time, physicists were stumped. Then, in the 1970s, the brilliant Stephen Hawking threw a wrench into the works. He discovered that black holes aren't completely black after all. Due to weird quantum effects near the event horizon, they slowly leak a faint glow of particles, now famously known as Hawking radiation. This means that over immense, almost unimaginable stretches of time, a black hole can completely evaporate and disappear, leaving nothing behind but this faint radiation. This made the problem even worse. Hawking's initial calculations suggested this radiation was completely random, like thermal static. It carried no trace, no memory of the beautiful, complex things that had fallen in, no information about the stars, planets, or even hypothetical astronauts it had swallowed. If the black hole disappears, and the information isn't in the radiation, then it seems to have vanished from the universe forever. This violates a sacred principle of quantum physics called unitarity, which basically guarantees that the past is always recoverable from the present. The universe, according to quantum rules, doesn't get amnesia. This paradox has haunted physicists for nearly 50 years, sparking a creative explosion of some of the wildest ideas in science. So, where could the information go? One of the most popular ideas is the holographic principle. It suggests that the information isn't lost inside the black hole at all. Instead, it gets imprinted or encoded onto the two-dimensional surface of the event horizon, like a cosmic hologram. All the three-dimensional stuff that falls in is projected onto this surface. This radical idea, born from string theory, even suggests that our entire universe might be a hologram projected from a distant, lower-dimensional boundary. Think about that for a second. Our 3D reality could be an illusion. Another possibility is that the information does escape, but in an incredibly subtle way. Perhaps it's hidden in tiny, delicate correlations within the Hawking radiation itself. For a long time, these correlations were thought to be impossible to detect, but physicists are now designing experiments and searching for clues. It would be like trying to reconstruct a whole library of burned books by analyzing the patterns in the smoke. It's incredibly difficult, but maybe not impossible. And then there are the more sci-fi sounding theories. What if black holes are gateways? Some physicists propose that the information isn't destroyed but is instead transferred to another universe, a baby universe born from the black hole's singularity. In this view, every black hole is a cosmic doorway, and our universe could be just one of countless others in a vast multiverse, with information safely stored in these other realms, forever beyond our reach. Pushing the boundaries even further, we have the firewall hypothesis. This idea suggests that anyone or anything falling into a black hole would be instantly incinerated by a wall of high-energy particles right at the event horizon. This would solve the paradox by destroying the information before it even gets a chance to enter. But it would also tear apart Einstein's theory of general relativity, which predicts a smooth, drama-free journey across the horizon. On the other hand, the EREPR conjecture offers a beautiful and elegant connection. It proposes that wormholes, Einstein-Rosen bridges, or ER, and quantum entanglement, EPR, are two descriptions of the same thing. Entanglement is that spooky quantum connection where two particles can be linked, no matter how far apart they are. This idea suggests that the information inside a black hole might remain connected to the outside universe through these hidden wormhole-like tunnels in the fabric of space-time itself. Theories like string theory and loop quantum gravity also weigh in. String theory imagines black holes not as empty voids, but as incredibly complex fuzzy balls of vibrating strings, with their internal structure holding all the information. Loop quantum gravity gets rid of the singularity altogether, suggesting that matter falling in gets compressed to an unbelievable density, and then bounces, allowing the information to eventually re-emerge in a new form. But this isn't just a technical debate for physicists. This paradox touches on deep philosophical and even spiritual questions. If the laws of physics insist that information cannot be destroyed, does that mean that on some fundamental level nothing is ever truly lost? Does every action, every thought, every moment of existence leave a permanent mark on the fabric of reality? Interestingly, this scientific intuition finds echoes in ancient wisdom. For instance, in Islamic theology, the Quran speaks of a divine record, where everything is accounted for, stating that not a leaf falls, but that He knows it. It emphasizes that every deed is meticulously recorded. It's a fascinating parallel. The idea that the universe itself functions as a perfect ledger, where no truth can ever be erased. Perhaps the information paradox isn't just about physics. It's about the nature of memory, accountability, and whether the cosmos has an unbreakable commitment to preserving truth. And we're no longer just talking about theory. We are living in a golden age of black hole observation. The Event Horizon Telescope gave us our first ever picture of a black hole's shadow. Gravitational wave observatories like LIGO and Virgo are letting us hear the cosmic chirps of black holes colliding millions of light years away. Future missions and telescopes will scrutinize the radiation around black holes, searching for the subtle signatures that might finally tell us how information is preserved. Meanwhile, scientists are creating analog black holes in labs using things like sound waves in exotic fluids to test these theories right here on Earth. Ultimately, the black hole information paradox is more than just a puzzle. It's a crucible, forcing us to forge a new, deeper understanding of reality. To solve it, we will likely need a complete theory of quantum gravity, a theory of everything, that finally unites Einstein's world of the very large with the quantum world of the very small. Solving this paradox won't just tell us about black holes, it will redefine our understanding of space, time, and existence itself. As we stare into these darkest regions of the cosmos, we find they hold the brightest clues. They reflect our deepest questions about who we are, what reality is made of, and whether anything is ever truly forgotten. The paradox is a mirror, showing us that the universe may be a place where knowledge, memory, and truth are preserved forever, in ways we are only just beginning to imagine. Thank you so much for joining me on this journey to the edge of reality. If you enjoyed this deep dive into the cosmos, don't forget to hit that like button, subscribe, and ring the bell so you won't miss our next adventure. Let me know your thoughts in the comments below.